Lesson 3N, Negative Feedback Example, Thyroxine. Thyroxine is a hormone produced by the thyroid gland found in your neck. The thyroid gland is an endocrine gland, meaning that it secretes a chemical into the bloodstream so that it's carried throughout the entire body. Thyroxine has a crucial role in heart function, digestive functions, metabolism, brain development, bone health, muscle control, and more. You can suffer from hyperthyroidism or overactive thyroid. This disorder can cause a goiter, weight loss, heat intolerance, fatigue, irritability, and bulging eyes. Here's an example of a goiter and the bulging eyes associated with hyperthyroidism. Hypothyroidism is an underactive thyroid. This can cause developmental issues for the young and low metabolic rate, weight gain, memory loss, and fatigue. For our example of maintaining homeostasis using negative feedback, we will look at thyroxine and body temperature, since thyroxine has a major role in controlling body temperature at a homeostatic value of 37 degrees Celsius. Cold temperature can be detected by cold receptors found in your skin, the cornea, and the urinary bladder. A message is sent to the hypothalamus of the brain, which is responsible for regulating body temperature, among other jobs. The hypothalamus will release a hormone called thyroid-stimulating releasing hormone, shortened to TSHRH, into the blood circulatory system. TSHRH, traveling through the blood, will arrive at the anterior pituitary gland of the brain. The TSHRH will stimulate the anterior pituitary gland to release thyroid-stimulating hormone, also known as TSH, into the blood circulatory system. Thyroid-stimulating hormone will then arrive at the thyroid gland in the neck and stimulate it to release the hormone thyroxine. Thyroxine will travel through the blood to all the tissues of the body to increase metabolism, or the burning of glucose and ATP to generate heat. We sometimes see this as shivering. As the body temperature increases, sensors in the body feed back this message to the hypothalamus, which responds by reducing the TSHRH release, effectively cooling the body down. This is an example of negative feedback. The warmth resulted in the body attempting to cool the body down. The response was to do the opposite to what the sensor detected. The buildup of thyroxine itself has an inhibitory effect on the anterior pituitary gland. When the concentration of thyroxine in the blood reaches a certain level, the production of TSH by the anterior pituitary becomes blocked. This is called feedback inhibition. This inhibition will prevent more TSH from being released from the anterior pituitary gland, which in turn reduces thyroxine production and further causes the body's temperature to fall. As the body cools due to the decrease in TSHRH, TSH, and thyroxine, this will be detected by the hypothalamus, which will increase TSHRH production. This will lead to an increase of TSH and therefore thyroxine in the body, and the body will warm up again. This is also an example of negative feedback, as the cool temperature feeds back to the brain, resulting in a warming of the body. These variations in body temperature are minor, and maintains the body's temperature near its homeostatic value of 37 degrees Celsius.